An organic compound has an empirical formula CH2O and vapor density of 45. What is its molecular formula? Given the atomic mass of carbon to be 12, hydrogen 1, and oxygen 16. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do so and click on the notification bell as well so as to be notified as soon as new videos are being posted here. And you can as well join the Telegram channel via the link in the description box. In the question above, we are being asked to calculate the molecular formula of the organic compound. An organic compound, generally known to be compound that consists of carbon, hydrogen, and any other element. It could be oxygen, sulfur, nitrogen, and so on. But in this case, we have just carbon, hydrogen, and oxygen. The good thing here is that we've been given the empirical formula to be CH2O, so we do not need to go through the process of calculating the empirical formula before we get the molecular formula. What we just need to do is to use the relationship saying molecular formula equals empirical formula times n, where n is a whole number multiple. But before that, we need to determine n. And how do we get n? Knowing that molecular formula is a multiple of empirical formula, that is, the empirical formula makes up the molecular formula. It could be one of it, it could be twice, it could be thrice, and so on. We have a relationship that says molecular mass equals empirical formula mass into bracket of n, that is times n, where n is a whole number multiple. The molecular mass is from the molar mass of the compound itself. The empirical formula mass will be gotten from the empirical formula, while n remains unknown. So to start with the molecular mass, from the question above, we are not given the molecular mass and we are supposed to be given. But in this case, we are only given the vapor density, which makes it easier for us to determine the molecular mass. So to get molecular mass, we'll be saying molecular mass equals vapor density times 2. So this is the formula we'll be using to determine the molecular mass of the organic compound. So this equals 45. From the question, we are given the vapor density to be 45 multiplied by 2, and this gives 90. So we have 90 grams per mole. For the empirical formula mass, from the formula we have CH2O equals, so we'll be summing the atomic mass of each of the elements present here. For carbon, we have one atom present, and atomic mass of carbon is 12, so we just have 12. Plus for hydrogen, we have 2 atoms present and atomic mass of hydrogen is 1, so that gives 2 times 1. And for oxygen, we have 16, 1 atom present, so and the atomic mass of oxygen is 16, so we have 16. This gives 12 plus 2 plus 16, which makes a total of 30, so we have 30 grams per mole. The whole number multiple n remains unknown, hence we'll be making n the subject. So from here, from the formula we've written above, we'll say n equals molecular mass divided by the empirical formula mass. Which equals, the molecular mass is 90 grams per mole, and the empirical formula mass we got 30, so 30 grams per mole, and dividing this we have n to be 3. So we've gotten n, the whole number multiple, to be 3. That is, for the molecular formula now, we now have thrice of the empirical formula in it. We'll be using the relationship that says molecular formula equals empirical formula times n. This simply means that the molecular formula consists of a multiple of the empirical formula. So here we have empirical formula from the question is given to be CH2O. So we have CH2O into bracket of the whole number multiple. We got that to be 3. And this equals, so we're multiplying whatever is in this bracket by 3. So we have C carbon, the first element present, with a subscript of 1. So say 1 times 3, we have 3. Then for hydrogen now, subscript of 2, 2 times 3, that is 6. We have 6. And for oxygen, 1, subscript of 1, 1 times 3 gives 3 as well. And that's all on that. So the molecular formula is C3H6O3, which serves as the final answer. With this, we've just come to the end of the solution to the question, and we've gotten the molecular formula of the organic compound to be C3H6O3. That will be all. Do not forget to subscribe and click on the notification bell so you don't miss out on more videos like this. You can leave your comments in the comment section below, like and share the video as well, and you can also join the Telegram channel via the link in the description box for better communications. Thank you.